These next ones then, we are having a word problem where we are going to give the equation modeling the displacement of d as a function of time. In other words, we're going to write the sine or the cosine curve like we did on those first ones, either in the form of y equals a sine of bx or cosine of bx, depending on what you have. So what you kind of want to do is read the problem, sketch out a picture of what it looks like, so then you can look at the graph and think about, well, what is it going to be? It says a buoy is floating at the seas, bobbing in simple harmonic motion with a period of 3 seconds and an amplitude of 9 inches. Its displacement d from sea level at t equals 0 is 0 inches, and initially it moves upwards. So it means it starts here at 0, 0. Initially it's going to move upwards. It has simple harmonic motion, so we're going to have our sine curve. The amplitude, it says, is going to be 9, and the period is 3 seconds, so one cycle would take 3 seconds. So I'm going to have d equals 9 sine of, again, we're going to have 2 pi over b to equal the period of 3. So I'm going to have 2 pi equals 3b. So b is going to equal 2 pi over 3. So I'm going to have 2 pi over 3. And instead of using an x, I'm using a t. And so d is equal to 9 sine of 2 pi over 3 t. T wants to look like a plus sign, but something like that. Move this up for number 14 here. So number 14 says a weight is at the end of a coiled spring and is pushed 9 centimeters above its resting point at time t. So it's going to start up here at 9 centimeters. Moves in downward, oscillating in simple harmonic motion, and completes one cycle in 2.5 seconds. Note that downward is in the negative direction. So it starts here, it's going to move downward and have simple harmonic motion, which tells me here if it's starting up here and moving downward, I have my cosine curve with an amplitude of 9, since it's starting 9 centimeters above there. So 9 times the cosine. One cycle takes 0.25 seconds. So 2 pi over b is going to equal 0.25. Now I probably would change 0.25 into 1/4 since I've got a fraction here. So I'm going to say 2 pi over b equals 1/4, and then I can solve by cross multiplying. So 8 pi is equal to b. I'm going to have 9 cosine of 8 pi t then, since I'm using as a function of time. And so d equals 9 times the cosine of 8 pi t would be my equation. Number 15 says an object moves in simple harmonic motion with a period of 5 minutes and an amplitude of 16 meters. At time t equals 0 minutes, its displacement is 0 meters. So again, this one's saying it's starting at 0, 0. It initially moves in the negative direction, so it's going to go down first and do my sine curve going in the negative direction first. My amplitude is 16, so I'm going to have negative 16 times my sine, since I have my sine curve. My period is 5 minutes, so 2 pi over b would equal 5. So 2 pi would equal 5b. So b is going to equal 2 pi over 5. So I would have 2 pi over 5t. And so d is equal to negative 16 sine of 2 pi over 5t. So you can see here, even though it said this one started and moved in the negative direction, it still had a positive amplitude because it started up here at 9. Where this one went in the negative direction first, I had the sine curve and it went negative first. It had a negative 16 there. Although technically the amplitude is 16, the value in front of my sine is negative 16 to show that it goes downward first. So it helps to sketch out the picture of your graph before you try to write your sine or your cosine curve.